All right, let's dive right in. If you're a student in science or engineering, you know the research grind is, well, it's a grind. But what if it didn't have to be? Today, we're talking about how you can use generative AI not just as a tool, but as a genuine research partner, something that can seriously level up your work.
So here's the million-dollar question, right? Is this new tech the savior we've all been waiting for? Is it going to solve all our problems in the lab or the library, or is there maybe a catch?
And the answer, really, all comes down to a crucial shift in perspective. The big mistake is seeing AI as a magic button, a simple task doer you can just offload work onto. But the smart way, the right way, is to think of it as a thinking partner. Because its real power isn't in the tool itself, it's in how you use it.
Okay, now before we get into all the cool stuff you can do, we have to talk about the risks. Seriously, to use AI well, you first have to understand all the ways it can go wrong. So let's look at the common traps and, more importantly, how to avoid them. First up is the big one you've probably heard about: hallucination. This is when an AI just makes things up. It'll generate an answer that sounds totally convincing, super academic and professional, but it's just factually wrong. And if that gets into your paper, well, you're in for a bad time. The bottom line here is simple. You have to verify, always.
Now, the second trap is a little sneakier. It's called Potemkin understanding. See, the AI can talk a great game. It can mimic the language of a field expert perfectly, but it doesn't actually understand the deep concepts underneath. It's just a brilliant pattern matcher. So what's the takeaway? You can't just blindly trust its reasoning. And look, this slide, even if you can't read the text, shows this perfectly. It's a real chat with Gemini about an electrical engineering problem. And you can see the user has to keep correcting the AI's mistakes, basically saying, nope, that's wrong, and the numbers you're using are completely different. It's just a stark reminder that even the best models get it wrong. You are the expert in the loop, always.
Okay, so we know the risks. Now, how do we actually get great results? Well, getting high-quality answers from an AI isn't about luck. It's about skill. It's about crafting smart prompts. Your ability to communicate clearly is what unlocks its true potential. So how do you do that? Well, effective prompting really boils down to three key things. First, be specific. Tell it the context, the format you want, the tone you need. Second, and this one is a game changer, assign it a role. Don't just ask a question. Tell it, you are a senior editor for the journal Nature. This focuses its output like you wouldn't believe. And third, guide its thinking. Tell it how to think. First, summarize this. Second, find its flaws. Third, suggest improvements.
So, with those prompting skills ready to go, we can get to the fun part, putting our AI copilot to work on actual research tasks. Let's see what that really looks like in practice.
Now, check this out. Here are two simple but incredibly powerful techniques. If an AI gives you an answer that's just kinda okay, let's call it a 60-point effort. Don't just accept it. Treat it like a student. Tell it, this is a 60-point answer. I need a 90-point answer. To improve, you need to add these specific details. And for anything complex, always make it think step by step. This forces the AI to show its work, which makes it so much easier for you to spot any errors.
So, where can you actually apply this? The possibilities are pretty much endless, but here are some of the biggest wins for science and engineering students. You've got academic translation and proofreading, running huge literature surveys, getting a hand with data analysis, generating code for tools like Tex and Wolfram, and even outlining whole presentations.
And this is a fantastic time saver. Anyone who's written a paper knows the absolute pain of formatting complex formulas in text. But here, with just a simple prompt, the AI spits out the exact code for a Laplace transform. You literally just copy and paste it into Overleaf and boom, a perfect equation. That is a huge win.
And it gets even more powerful. Here we're seeing the AI generate code for Wolfram, which is a super sophisticated tool for data analysis. It's writing the code to fit a curve to experimental data and then plot the whole thing. This automates a really complex task that could otherwise take you hours of frustrating work.
So, as we bring this all together, we have to come back to the single most important idea. No matter how incredible these tools get, you are always the one in the driver's seat.
This analogy is perfect. Using AI in your research is exactly like using a self-driving car. It's an amazing assistant. It can do a lot of the heavy lifting. But if there's an accident, if a hallucinated fact makes it into your final paper, the responsibility doesn't lie with the car. It's on you.
And that is the key takeaway here. It's all about balance. Use these tools to push your research further and faster than ever before, but never, ever outsource your critical thinking. The final integrity, the quality of your work, that is and always will be yours alone.
So I'll just leave you with this one question to think about. This technology isn't just a tool to be used, it's a partner to be cultivated. So, how are you going to cultivate your thinking partner?